Good morning, students. Today we will learn about the exercise 5.4. In exercise 5.4, you will use some formulas in logarithmic function and exponential function. First of all, I want to tell you about the formulas of logarithmic function. First, the formula of log p into q. The log of p into q is log of p plus log of q. Log of q. In product, when the log product two functions are given, that is p into q in the logarithmic function, then you will take log p plus log q. And if the logarithmic function in this form p upon q, then the formula is log p minus log q. And third one is log p raised to power n. Log p raised to power n is n log p. And next one is, if the formula is in the form log of p upon q is there, log p is given, log p into q is given. If the formula is log p square, then again you have to apply this one to log p. And derivative of, what is the derivative of exponential function e raised to power x? The derivative of exponential function is e raised to power x into derivative of x. And you know the value of derivative of x. The derivative of x is 1, so it will become e raised to power x. And similarly, sixth one is derivative of log x, logarithmic function. The derivative of log x is 1 upon x into again derivative of x, this theta, and you know the derivative of theta is 1, so it will become 1 upon x. This is the derivative of log x. Now these formulas you will use in the exercise 5.4. Now let us start the exercise 5.4. Now students, come to the exercise 5.4. Now we will start the exercise 5.4. Question number first. In question number first, you have to find out the differentiation of with respect to x, and the function is given, that is e raised to power x upon sin x. So we will find out the differentiation here. Y is equal to e raised to power x over sin x. This is given. So differentiate both sides with respect to x. Both sides with respect to x. So it will come dy upon dx in LHS and RHS, derivative of e raised to power x upon sin x, and here derivative of u upon v. And you know what is the derivative of u upon v? The derivative of So derivative of sine inverse x, this is chain rule. Here e is to power x and here x is 1, so that's why it will come dx upon dx1. But here x is sine inverse x, so you have to find out the derivative of this term. Further implies dy upon dx is equal to e raised to power sine inverse x as it is, and derivative of sine inverse x. What is the derivative of sine inverse x? That is 1 upon root of 1 minus x square. Now what is the answer? The answer is dy upon dx. Multiply this term, it will come c e raised to power sine inverse x upon root of 1 minus x square. This is the required solution of question number 2. This completes the solution question number 2. Now we will start the question number 3. In question number 3, you have to find out the differentiation of e raised to power x cube. In question number 3, you have to find out the differentiation of e raised to power x cube. Yes, again e raised to power x. What is the derivative of e raised to power x? I am only telling you about e raised to power x. Derivative of ex is ex. But here the function is e raised to power x cube. So let us start the solution. Let y is equal to ex raised to power 3. After that, differentiate both sides with respect to x. Then it will come dy upon dx is equal to derivative of e raised to power x cube. After that, dy upon dx as it is, and derivative of ex cube is, this is theta. So derivative of e raised to power theta is e raised to power theta into, means theta is x cube, into again derivative of this theta. What is this theta? That is x cube. So derivative of x cube. After that, dy upon dx implies e raised to power equal to e raised to power x cube as it is. What is the derivative of x cube? The derivative of x cube, x raised to power n, that is nxn minus 1, so it will come 3x square. And again derivative of x, that is dx upon dx, will come 1. So it is coming 3x square into ex raised to power 3. This is the value of dy upon dx. This is the solution of question number 3. Now let's come to the question number 4. What is question number 4? The question number 4 is sine of, question number 4 is sine of tan inverse e raised to power x cube. This is the question. Tan inverse e raised to power minus x. E raised to power minus x. This is the question. Now let us start this question. What is given here? Sine of tan inverse x. Sine of tan inverse e raised to power minus x. Now let us start the solution. Let this function is y. Y is equal to sine of tan inverse e raised to power minus x. So it will come, differentiate both sides with respect to x. Both sides with respect to x. So it will come dy upon dx equal to again here theta is e raised to power minus x. So again you have to find out the derivative of e raised to power minus x. So further implies it will come dy upon dx as it is cos of tan inverse e raised to power minus x into 1 upon 1 plus e raised to power minus 2x. Because we are e raised to minus x into 2, so it will come e raised to power minus 2x. Yes, again derivative of e raised to power minus 6. The derivative of e raised to power minus 6 is e raised to power minus 6 as it is again derivative of minus x. So it will come minus e raised to power minus x. Because derivative of e raised to power minus x is e raised to power minus x. Again derivative of theta. So theta is minus x here. So derivative of minus x is 1. So it is coming minus e into e raised to power minus e raised to power minus x. After that you can write this term as multiply minus e raised to power minus x cos of tan inverse e raised to power minus x upon 1 plus e raised to power minus 2x. This is the solution of question number 4. This is the required solution. This is the value of dy upon dx. Now let us start the question number 5. In question number 5 you have to find out log of, you have to find out the derivative log of, the function is question number 5 log of cos e raised to power x. Log of cos e raised to power x, it means it is logarithmic function. You have to find out the derivative of logarithmic function. What is the derivative of log x? The derivative of log x is 1 by x and again derivative of x, that will come 1. So let us start the solution. Let y is equal to cos of e raised to power x. Now differentiate both sides. Differentiate both sides with respect to x. Both sides with respect to x. So it will come dy upon dx equal to derivative of cos of e raised to power x. Sorry, log is also there. Y equal to log of this. This is the question. Log of cos ex. Derivative of log of cos ex. Now here derivative dy upon dx is as it is. Now what is the derivative of log x? Let it be x. So derivative of log x is 1 by x. What is x here? That is cos e raised to power x. Again derivative of x. So what is x here? This term is x. It will come cos e raised to power x. You can fifth question is complete. Now come to the question number 6. In sixth question, you have to find out the derivative of ex plus ex square plus ex cube plus ex raised to power 4 plus ex raised to power 5. This is the question. Ex plus ex square ex cube. Yes. Question number 6. Question number 6 is ex plus ex square plus ex cube plus ex4 plus ex raised to power 5. So let us start the solution of question number 6. In sixth question, let y is equal to e raised to power x plus e raised to power x square plus e raised to power x cube plus e raised to power x4 plus e raised to power x5. Now find out the derivative. So differentiate both sides. Differentiate both sides with respect to x. With respect to x. So what will come here? It will come dy upon dx. And in first step you can write derivative of all term. After that you can separate the term like this. I am separating the term. In first you can write here derivative of whole term like that. Now I am separating the term derivative of ex plus derivative of ex square plus derivative of ex cube plus derivative of ex4 plus derivative of ex raised to power 5. So what is the derivative of ex? The derivative of ex is ex and plus here LH is dy upon dx as it is. The derivative of ex square, this is theta, so derivative of ex is ex. So ex square as it is, again derivative of x square, this theta, x square. Similarly here derivative of ex cube. Derivative of ex cube is ex cube into derivative of x cube. Plus next term derivative of ex raised to power 4 is ex raised to power 4 into derivative of x raised to power 4 plus derivative of e raised to power e into x raised to power 5 is e x raised to power 5 derivative of x raised to power 5. Now you will find out the derivative here. So it will come dy upon dx. Yes, the derivative of first term is e raised to power x. E raised to power x and the derivative of x square is 2x. So it will come plus 2x into e x square plus derivative of x cube is 3x square and then this term as it is ex cube as it is. After that derivative of x4 is 4x cube and ex raised to power 4 as it is this term. Then derivative of x raised to power 5 is 5 x raised to power 4 into ex raised to power 5. This is the solution of question number 6. After that, if you want to take common, you can take common. Otherwise, up to this, it is complete. Now, this is the solution of question number 6. Now, start the question number 7. In question number 7, you have to find out the derivative of e raised to power. You have to find out the derivative of e raised to power root x This root I am writing here in the form of 1 by 2. After that, d by 1 is equal to, you know that x is to power n. What is the formula of x is to power n? This, let it be x. So 1 upon 2 e raised to power root x whole raised to power 1 by 2 minus 1 into derivative of e root x. Means x raised to power n x n minus 1, again derivative of this x. What is x here? That is e root x. After that, yes, it will come dy upon dx is equal to 1 by 2 into e root x whole root, because it will come 1 by 2 minus 1, take LCM minus half, so minus half you can take in the denominator 1 upon e root x. Now derivative of e root x is, that is e root x as it is, derivative of ex is ex, again derivative of x. What is x here? That is root x. Here theta is x. So 1 upon 2 into whole root e root x into e root x as it is. What is the derivative of root x? That is 1 by 2 root x. Again that formula I am writing here, because derivative of root x is 1 by 2 root x, because this is x raised to power half, and you can apply the formula x raised to power n, then nx n minus 1 will come that term. After that, in numerator e root x upon, here 2 into 2 it will come 4, then root x, then e root x. After that, you can write here dy upon dx is equal to e root x over 4, combine these two terms, root of x into e raised to power root x. This is the required solution of question number 7. This completes the question number 7. Now students, come to the question number 8. In each question, you have to find out the differentiation with respect to x. The function is log x. Now let us start the solution. Let y is equal to log x. On differentiating both sides with respect to x, differentiate both sides with respect to x. So it will come, yes, it will come dy upon dx, and here derivative of this term, that is log x. After that it will come dy upon dx, derivative of log x is 1 upon log x, because derivative of log x is, I am writing here, derivative of log x, that is equal to 1 by x, and again derivative of x, that will come 1, and here x is log x, so it will come 1 upon log x, and again derivative of log x. Here also derivative of x, that will come 1, so we are writing here only 1 by x. After that, dy upon dx is equal to 1 upon log x, and derivative of log x is 1 by x, and derivative of x is 1. So we can write this term as 1 upon x into log of x, dy upon dx. This is the dy upon dx. This is the required solution of question number 8. This completes the question number 8. Now come to the question number 9. In question number 9, you have to find out the derivative of cos x upon log x. Means again two functions are there. One is trigonometric function and other is logarithmic function. So it means you have to apply the formula u upon v here. Question number 9 is cos x upon log x. with respect to x. Therefore, it will come dy upon dx equal to derivative of cos x upon log x. Cos x over log x. After that, we will write here yes, it will come yes dy upon dx. Dy upon dx. You will apply here u upon v. So u upon v is here log x whole square or log square x. You can write any term. After that, formula is u dash v. You have to find out the derivative of log x, derivative of cos x because u is cos x, and log x as it is. After that, minus cos x as it is, derivative of log x, derivative of log x. After that, derivative of cos x is minus sin x, this one, minus sin x into log x, minus cos x as it is. What is the derivative of log x? That is 1 by x whole divided by log x whole square. Then dy upon dx is equal to, take LCM here, x is LCM, so it will come minus x into sin x log x minus cos x, and this x as they come in the denominator, it will come x log x whole square. So this is the required solution of question number 9. Our 9th question is completed. Now we will start the question number 10, and that is the last question of this exercise. Write down the 10th question. The 10th question is, you have 10th question, you have to find out the derivative of this function. And what is that function? The function is cos of log x plus e raised to power x, and where x is greater than 0. Now let us begin the solution of this question. Let y is equal to cos of log x plus e raised to power x. This is the function. Now find out the derivative. Differentiate both sides. Differentiate both sides with respect to x. With respect to x. It will come dy upon dx. Now derivative of cos of log x plus e raised to power x. So it will come derivative of cos theta. What is the derivative of cos theta? Minus sin theta. Minus sin theta. What is theta? This is cos theta. And what is theta here? Log x plus e raised to power x. Again